Hi, I'm Woody Huffines, and I own the Nerds to Go in McKinney and Frisco, Texas, and this is Tech for the Untechnical. So, what is this internet thing, and how does it work? Our first question is, what is the internet? We use that word a lot. We talk about the internet. It's on the internet. It's in the cloud. The internet. What is the internet? The internet is essentially the communications network, or the process or protocol by which we connect over the internet or over the communication lines to connect two resources that are just about any place in the world, quite literally any place in the world. So the internet is the protocol that we use to connect two devices in various places all over the world. So that when I pick up my phone, for example, sitting here in my house, and I want to connect to ESPN to see what the score was of a football game yesterday over the internet, how does that work? Well, it works through a thing called the Internet Protocol. It's TCP/IP, the Terminal Control Protocol or Internet Protocol, so that each location or each device or each resource on the internet has an address, just like an address that you have for your house. Somebody sends you a letter, they put an address on it, and the letter comes to your house because that address allows the Postal Service to route that letter to where it belongs. At the end of the day, that's at your house. So how do internet addresses work? Well, right now we primarily use what's called IPv4 or Internet Protocol version 4. And the Internet Protocol version 4 is a set of numbers, 4 numbers. Each of the numbers go from 0 to 255. So you have 0 to 255 dot 255.255.255. So there are 4 domains, if you will, that you use to identify an endpoint for communication or the beginning point for communication. Your house has an IP address. If you have an internet provider and you go out on the internet knows where you are or where to send communication based on your IP address. And your IP address might be 136.205.68.3. Don't know what it is, but that's the kind of process that the internet goes through to route things. And the routers on the internet take that information in that set of numbers to route information to where it belongs and to send information back to you. So if you take 256 times 256 times 256, which is the number of changes or the number of addresses in each of those address blocks, because it's 0 to 255, so you got 256 numbers. So if 256 times 256 times 256 times 256 equals about 4.3 billion possible internet addresses. So if you want to send someplace, you got 4.3 billion opportunities or 4.3 billion addresses to send information to. And we'll talk a little bit about internet address scarcity here in a minute. So how do the routers determine where to send the messages? It looks at those blocks of numbers, and the router has what's called the Border Gateway Protocol or BCG that says, okay, if I get a message that's for this internet address, I send it that way. And the thing about the internet that's interesting, it is a robust network. It's a self-healing network. When you send something out on the internet, each router looks at the routers that it's connected to, and it finds the least busy router to send that information to go to the next point, to the next point, to the next point. Another thing that a lot of people don't know about the internet is when you send a message out on the internet, your computer breaks that message up into little blocks, and those little blocks then get communicated over the internet protocol to the place that you send them to. So if you send an email and you say go, that email may be broken up into 4 blocks, and one block may take one route to get to the endpoint, and another one may take another route to get to the endpoint, and when they get to the endpoint, they get assembled in the right order and presented to whoever you sent the email to. It's pretty cool, isn't it? So how does this router thing work? Well, for a moment, if you will, visualize your block, the street you live on. If you're standing on one end of the block and you look down the block and there's 4 houses on each side of the street, each of those houses has 2 stories, and each of those stories has 4 or 5 rooms in it. So when you send a message to one room or another room, the routers or the places or the resources that move that message around would use information based on an address, Internet Protocol address in this example, that looks at Where does it need to go from where it is? So let's go back to the street. Let's say that the houses on the left-hand side of your street, the first number in that 4-block number is 1, and the ones on the right side of the street are 2. And then the next digit in the block of addresses refers to which house it is. First house on the left would be 1.1, and the second house would be 1.2. On the right-hand side of the street, the fourth house would be 2.4. So, if you're on the left-hand side of the street and you hand a router an address that has a 2 dot anything, that router goes, oh, no, that's across the street. And it just sends it to some router across the street, whichever one is the least busy one across the street it gets to. When it gets to that router looks at it and goes, ah, this is a 2 dot, that's my side of the street. And then that router looks at the second number and it says, ah, this is a 2.4 address. That means that I need to send this message to the fourth house on the right-hand side of the street. So it sends it down to the fourth house. And the router in the fourth house looks at it and goes, aha, this is a 2.4.2 address. Well, 2.4.2 means I need to send it up to the second story because the rooms on the second story are 2.4.2 addresses. And then the router on the second floor would look at it and go, yeah, 2.4.2, that's me. I need to send it to room number 3. So 2.4.2.3 would be the third room on the second floor of the fourth house on the right-hand side of the block. So any place that you drop a message in any one of those rooms, if you hand a router that's for that room a message and that router goes, oh, wait a minute, this is a 1 dot address and I'm on the 2 dot side of the street. It sends it across the street immediately to one of the routers on the left-hand side of the street so that it goes, oh, yeah, 1 dot, that's me. The internet works by having IP addresses, and those IP addresses, the routers know that that IP address is over that way and this IP address is over this way, and it just resolves down through that cascade of numbers until it gets the information that you're sending to the place it belongs to and the information from wherever you're asking it to where it belongs. If you go to your browser right now and you type in 205.251.243.103, I think. 205.251.242.103. Anyway, that's the IP address for Amazon. So if you went to your browser and you typed in those numbers, 205.252.142.103, you'd get to Amazon. Kind of hard to remember. I don't know why I remember that. I wrote it down the other day and it's kind of sticking with me. But at the end of the day, you don't type in an IP address, you type in a name. And after you type in that name, boom, the information goes out there and gets to where you want it to go. So when you request something, you request a website, all you do is type in the name and the website pops up. Now, how does that work? Well, there's a resource on the internet called the DNS, or Domain Name Server, and it's kind of like an address book for the internet. If I ask my phone to call my son Josh, my phone doesn't know who Josh is, but it knows that I have a contact list. So if I say call Josh, phone says, wait a minute, let me go to the contact list, and it says, oh yeah, okay, here's the phone number that's associated with Josh, and it calls Josh. Well, the Domain Name Server does the same thing. When you type in Amazon.com or LL Bean or the New York Times, it goes out to a domain name server. The domain name server resolves to an IP address and sends that communication to the appropriate IP address by the routers doing their router thing and sending the information there, and then the information comes back after you've established that connection. Now, let's go back to that internet address scarcity problem. IPv4, which is the 4 blocks of numbers, only has about 4.3 billion possible IP addresses. And theoretically, it's 4.3 billion, but it's really less than that because of reserved blocks and because of company blocks and because of home blocks. There's a bunch of IP addresses that have been kind of segregated that aren't useful for public internet routing. So it's significantly less than 4.3 billion. But we know we got probably a lot more than 4.3 billion resources on the internet. Good Lord, I've got probably 25 things in the house between the Amazon Alexas and the phones and the tablets and the computers and the smart televisions and the Ring door. Anyway, there's a whole lot of stuff in my house that makes it even bigger. So how does that work out? If we've got more than 4 billion devices connected to the internet and only 4 billion device locations on the internet using IPv4, how does that work? Well, at your house, you have a router, and that router is default from your ISP, what's called a NAT, or Network Address Translation Router. So that router creates an internet, if you will, inside your house using a block of IP addresses. Most routers use a 192. So my computer that I'm working on when I'm sitting in the den with a laptop, that computer might be 192.0.0.4. So when I request a resource from the internet, say I'm going to go out to browse Amazon.com and I type Amazon.com, it communicates with the router inside my house. My router inside my house knows that it's that laptop that's requesting that communication. So then it sends the request out on the public internet to Amazon, and when it gets a response from Amazon, it remembers that this communication was going on with that laptop. So I've got effectively a subnet that's created inside the house by my router inside the house. So to wrap it up, that's how it works. Every resource on the internet has an IP address. That IP address is 4 sets of numbers from 0 to 256. The routers know which way to send that information, so when you request something from an internet resource, the routers route that information towards that resource location and return the information to you. And that you have an internet that's inside the house that's built by your network address translation, or NAT router, inside your house. That's the way it works. So how does the internet work? Well, the internet is basically the set of internet protocol addresses. And the way it works is the routers that are on the internet just route the information towards the resource that you request when you type something into your browser. And when you type something into your browser, the domain name server translates the words that you type in into an IPv4 address, and that IPv4 address is resolved by the routers as they send that information out and bring the information back to you. It's Tech for the Untechnical. If this information is helpful to you, click the subscribe button below, ring the notification bell, and when we put one of these out, you'll get notification that there's one out. I'm Woody Huffines. I own the Nerds to Go in McKinney and Frisco, Texas. This is Tech for the Untechnical. Hope to see you again.